Let us see open delta connection. Open delta or V connection. If three single phase transformers are connected in star, and if one of transformer become faulty, if one of the transformer become faulty, then three phase supply is not possible by this connection. Is not possible. How we can see it? So this is one transformer having faulty winding, and second transformer is here. So you have only these two terminals, so you will get this voltage, that will be this voltage plus this voltage, algebraic sum, and that will be a single phase only, right? And this terminal is not available, so three phase supply is not possible. Whereas if three single phase transformers are connected in delta, if single phase transformers are connected in delta and one of transformer become faulty, then also three phase supply is possible, but with reduced capacity. Right? Let us see how. Say I have this delta connected transformer, right? This is our YB, and fault occur in this winding. So this winding will be replaced by open circuit, and the winding will be like this. This is R, this is Y, this is B. So if you see here, voltage between R and Y is VRY, right? And voltage between Y and B is this voltage. You can see Y is here, B is here. So voltage across this winding is voltage between Y and B. Voltage across this winding is voltage between R and Y. What about voltage here across open terminal? So it is R terminal, it is B terminal. So we want to find voltage across this open terminal. If this voltage is equal to this voltage in magnitude and it is creating proper phase difference, then we can say three phase supply is available. So we are interested in voltage between open terminal, that is R and B. That voltage by following phase sequence is VBR, right? Now let me show current here. So current in this is say IR, IY and IB. Say this is secondary side. So I can write voltages following phase sequence R, Y, B. If line voltage is V, so VRY can be written as V, and if I am taking VRY as reference, so V angle 0, VYB will be V angle minus 120 and VBR will be V angle plus 120, right? And for closed path, the voltage sum of these three voltages will be 0. I can write here, for closed path, VRY plus VYB plus VBR equal to 0. I want VBR because that is voltage across open terminal. So VBR I can write here, minus VRY minus VYB. Minus VRY is V angle 0, so I will write V angle 0 minus, and minus VYB is V angle minus 120. So I can write here VBR as minus V common, and it is 1 angle 0 plus 1 angle minus 120. So 1 angle 0 is 1 only, and it is expanded by R angle theta, that is R cos theta plus J sin theta. So 1 cos 120 minus 120, cos minus 120 is cos 120, that is minus 0.5, so it will be minus 0.5 plus 1 sin minus 120, that will be minus only, minus J sin 120 is root 3 by 2. So it will be minus V 0.5 minus J root 3 by 2, and I can rewrite it as, I can take minus inside, so it will be V in bracket minus 0.5 plus J root 3 by 2. So it is what? Cos 120 plus sin 120, that is nothing but 1 angle 120. So I can write this as V angle 120. Okay. So VBR, that was the voltage across open terminal, VBR is coming as V at an angle of 120. We can see balance voltage was 120, and after opening also we are getting same voltage, that is the voltage is constant of same magnitude and with proper phase difference. So this is what balance supply, right? So we can say voltage between open terminal is same and we can write here that three phase balance supply is available. Balance supply is available. Okay. So this is what the open delta connection is able to supply three phase supply. Now what about capacity? So we can see in case of delta, line voltage, phase voltage are same, but line current and phase current will be different. Whereas in open delta you can see the line current and phase current are same. Here IR is coming from here, IY will be the algebraic sum, and IB is coming from here. So I can write here capacity, that is kVA rating. So kVA of delta will be written as root 3 VLIL. But for delta, IL is root 3 IPH. So I can write here root 3 VL root 3 IPH. So it is what 3 VL IPH. For open delta, kVA open delta, it will be root 3 VL IL. Mind you, IL is equal to IPH in open delta. For open delta, IL equal to IPH. So I will put it here and it will remain as it is root 3 VL IPH. So if I compare these two kVAs, so I can write here kVA delta by kVA V open delta by kVA delta will be written as root 3 VLIPH by 3 VLIPH. So it will come as 1 by root 3. We can say kVA of V connection is 1 by root 3 times of kVA of delta, that is 0.577 of kVA delta. So it was expected that if one of transformer is faulty, then remaining two transformer will handle 66% of load, but it is not 66%, it is what, 57% of total load, right? The capacity will reduce, capacity will become 57.7. so this is how the kVA loading is there. Along with this, with phasor, that is not required here, the operating power factor of transformers are different. Operating power factor of transformers will be cos 30 plus phi for one transformer, and for second transformer it will be cos 30 minus phi, right? So this is what V connection. What are the advantage of V connection? That supply is continue during faulty condition also, during faulty or maintenance also. We can go for maintenance during faulty and maintenance condition. Limitations of this connection is that with increase in load, secondary terminal voltage become more unbalanced. Secondary terminal voltage become more unbalanced, right? And second limitation is voltage regulation and operating power factor, as we have seen power factor. So voltage regulation and operating power factor of both transformers are different. Talking about application of this V connection, so very first is the place where three-phase supply is must, right? So where three-phase supply continuity is must. During faulty also it will continue supply. Continuity is must. And second, in service, it can be used as in service in developing area where full growth of load require several years, right? Require several years. So we will use two transformers at start in the beginning to supply three-phase supply, and when load increases in several years, we will put another transformer to connect them in delta to meet the requirement. So that's all about V connection or open delta connection.